Hello everyone, my name is Brittany, and today we're going to be talking about how to do a derivative using the power rule. It's very simple once you get the hang of it. First, we're going to talk about the definition of a derivative. So you have a graph, you have your y-axis and your x-axis, and then you have a function whose line looks something like, and then you want to know the slope of this graph at this exact point. So that would be a line that looks like this. This is the tangent line. The slope of the tangent line is just the derivative. So you would take this function and find the derivative. So the components of a derivative for the power rule . The initial equation is going to look something like f of x equals x to the n. Now f of x just means function, nothing else. Now, it doesn't have to be f of x. It can be h of x, g of x, y, z of x. It doesn't matter. All of these are the same thing. They just mean function. This is your variable. And this is going to be your exponent. Your exponent can be any number. It can be 3, 2, 17, 1001. It does not matter what your exponent is. It's any number. Your variable can be any letter, A through Z. It does not matter. It's just a variable. So when you see a letter, don't get scared. Now, for the answer, the after equation, so we'll say and we're going to put our initial up here. Our initial was f of x equals x to the n. All right, for our answer, instead of f of x, we're going to say f prime of x. This means derivative, that's all. When there's a prime, there's a little apostrophe between the letter and of x, or after y, it would be y prime. That just means derivative, nothing else. You're going to say equals, and what we do to get the power rule, the steps are, we're going to bring this in front of the x. So n, keep your x, and then up here for your exponent is n minus 1. And that's it. Very simple. Sometimes, though, you will right here in front of the x in your initial equation, you might have a constant. In that case, it would be f of x equals constant x to the n times x to the n. And we're going to say constant is c, right here. So in that case, it would be, let's say, down here, f of x equals c times x to the n. F prime of x would be c times n, x n minus 1. You just keep the constant out front and multiply the constant and the exponent together. Also, another exception would be this exponent. When n equals 1, there will be no variable. The x will go away in your answer because x, when when n equals 1, x will be 1 minus 1. You see, 1 minus 1 would equal x to 0. And anything to the 0 power is 1. So it would just be 1. And when you multiply n times 1, it's just n. So we just don't do anything with it. It's just n. It goes away. Now let's do a few examples. Okay. We're going to start off very simple. F of x equals x squared. We're going to start with our notation. F of x turns into f prime of x. Prime of x, so the derivative, because there's a prime, you bring your 2 down, right? Bring this down, 2 times x, and then our n is 2, that's our exponent, so 2 minus 1. And that's equal to 2x to the first. Very simple. Let's do another one. We'll say g of x, because they're all the same, is x to the 7th. G prime of x, don't forget your prime, it's very important. You bring your 7 down, so 7x, 7 minus 1. So it's just 7x to the 6th. Now we're going to do one where there's a constant. That would look like this. So we have, we'll say y equals constant 3x squared. So when we have c x to the n, here's our c, here's our x, here's our n. So start off with your notation. Y prime is c, so we keep the 3 right here. 3 times n, bring down your 2, 2x, 2 minus 1. So now we multiply the 3 and the 2 together. That equals 6x to the first. Very easy. Now we're going to do one where we have our exception of when n equals 1. Now when n equals 1, it's not going to say x to the first. It's just going to be x. So we're going to say h of x equals, let's say 17x. So in this problem, you have a constant and you have our exception of when x equals 1. So here we have h prime of x. Remember, we keep our constant. We keep our constant out front. So 17 times, and up here our n is 1. We can bring it down if you want to. We can bring our 1 down here. So times 1, x, 1 minus 1. So that equals 17x to the 0. This isn't a thing, so it's 1. So 17 times 1, the answer is 17. All right, so if you'd like to grab a piece of paper, I'll do 2 or 3 more examples that I'd like you to follow along with. I'm gonna erase this. Okay. All right, so number 1 for you is going to be f of x equals x to the 5th. Now I'd like you to pause it right here and try your best. So after you would unpause, I'm going to do f prime of x. Remember our first step, bring down our 5. 5x, 5 minus 1. What is that? 5x to the 4th. All right, there you go. Got it right? I hope so. So 2 for you will be, let's say y. Y equals 3x to the 5th. All right, so again, pause it and try your best. If you didn't get it last time, you'll get it this time. So y prime is going to be, remember, this one has a constant right here, so we keep it out front. Then we bring our 5 down. And then 5 minus 1 at the top. So remember, we multiply these two. So 3 times 5 is 15. X, 5 minus 1 is 4. Okay, one more. We're going to do our exception. H of x is 300x. Remember, this is our exception. When n equals 1, there's no variable. So pause it and try. That's our notation. Okay, so when you pause it, unpause, our constant is 300. Just because it's a big number doesn't mean it changes anything. It's still a constant. So 300 times, we have our imaginary 1 up there. If you feel better about it, we'll bring it down. So times our 1, x, 1 minus 1. So that's 300 x to 0. And this equals 1. So we can just make it go away. It's just equal to 300. So as you can see, derivatives are not hard. It's very simple as long as you get the hang of it and follow the exceptions. When we have a constant, when n equals 1, it's very, very easy. All right, thank you.